Hello, you absolute legends. We're going to draw Lewis dot structures of some atoms. Now, Lewis dot structures are meant to highlight the valence electrons around an atom. And eventually, Lewis dot structures will be able to show the geometry, bond angles, and connectivity of the bonds between atoms. So let's do some Lewis dot structures of sodium, oxygen, and fluorine, these individual atoms here. So the first thing we need to do is locate sodium on our periodic table and convince yourself that this is the box that sodium lives in. Now, 1, 2, 3. In sodium's third shell, its valence shell, it has uno electrons. So the Lewis dot structure for sodium looks like this, just the one uno electron. Now I put the uno electron at the noon or north position, but it could really go anywhere. It's just got to go one dot right there. So this would be a neutral sodium atom. Now the nice thing about Lewis dot structures, or excuse me, the nice thing about looking at the periodic table here is you can predict what common charge sodium would have because it only has one valence electron. Sodium, like every atom, is going to want a full row of electrons. Its first row and its second row are filled. I don't have them drawn in there right now, but they're filled with arrows of electrons. And in the third row, it has uno electron. So sodium is at a precipice. It can either try to get rid of the one electron and expose its full layer beneath, or it can rummage around and try to steal 7 electrons. It's just going to get rid of the one electron. So the Lewis dot structure for a sodium atom is just this with the +1. We just draw that one electron. We just don't draw that one electron there. Oxygen. We do the same treatment for oxygen. We find it on the periodic table and fill in. I'm just going to fill in the valence electrons, boron, carbon, nitrogen, oxygen. So this is the box of neutral oxygen. I'll fill in all of them because it's only just dose more. So oxygen has 8 electrons total. 2 in the inner shell, in the first shell, 6 in the second shell, and for oxygen, the second shell is the valence shell. So neutral oxygen has 6 electrons. Watch how I draw my 6 electrons. This is something to pay attention to. 1, 2, 3, 4. Spread your electrons, 5, 6. There's only 2 electrons to a side. Sit here and do this. We don't do that. Okay? When we build molecules out of these pictures and try to estimate bond angles and connectivity, this is not helpful. Okay? We try to put it on the north, east, south, west edges and spread your electrons before you pair them up. The oxygen, the common charge for oxygen, if you look at it on the periodic table, if you look at my periodic table here, you can see that oxygen, like every atom, wants to have a full level or row of electrons. It can either steal 2 or lose 6. It's more likely going to steal 2 electrons from somebody before it can give away its 6. So we're going to add those 2 electrons in there. 1, 2, 3, 4, 5, 6, 7, 8. -2. We have 2 more electrons, so it's a -2 charge. Finally, fluorine. Fluorine. This is the same box this is fluorine box here for a neutral fluorine, really just next door to oxygen. So with our Lewis dot structure, we start with the F and then spread our electrons. And that is a neutral fluorine atom in a Lewis dot structure, drawing only the valence electrons. Fluorine, at its precipice, is going to make a decision and only steal one electron as opposed to losing 7. So if fluorine gains one electron, it would have 8, 5, 6, 7, 8, -1. Hope this is helpful for drawing Lewis dot structures of atoms. Thank you.